Hey guys, this is my first video as a chopped CS major, unemployed. We are gonna do Leetcode, whatever Leetcode question this is. I gave myself a 17-minute timer, so let's get to it. Delete leaves with a given value. You are given a binary tree root and an integer target. Delete all the leaf nodes with value target. So every leaf node with this parameter target, we delete. So let's say in this first example we have 2, and let's see why this example works. So we set we set 2 to, so we set the parent of 2 to none, and basically we knew that we should have deleted this 2 instead of the above 2 because this 2 had no children, so as defined by leaf node. So what I'm thinking is we can just I mean, yeah, it's gonna be O of n either way. We got to check every leaf. We got to go down to every leaf path. And once we're at the leaf, we can just delete it, right? I'm just trying to think of anything, edge cases I may be missing. Is we covered a case where the target is not the leaf. So we just ignore it if it is not a leaf. We do that by checking if so I'm thinking is this, right? Three. Oh, this is the edge case we're missing. So we have 3. This becomes a new leaf, and this becomes a new leaf. So yeah, this will definitely require some recursion because if we're at the root of 3, right? If it has no children, yeah, wow. This might have to be a post-order traversal where we have visited both kids before visiting the root. Because we only know what to do with the kids. We only know what to do with the node we're on after we have visited his children. For example, if we set this root dot right to none and come back to this 2, then we'll see that it still has a root dot left that is not a leaf node, right? So yeah, post-order traverse. I think we got our algorithm, boys. So post-order traversal from the root. If not root, return none, obviously. But we also have another base case. If root dot val is equals to the target, right? and root dot left equals none, and root dot right equals none. Then we got to return none for the current route we are on. I see. So let's do this right now. If not root, return none. If not anyways, sorry. Root dot left equals self dot remove leaf nodes of root dot left, and then root dot right equals self dot remove leaf nodes of root dot right. And this base case, so let's say we're at, let's forget about this one, right? Let's say we're in the tree 252, right? If we get to this 2, no, so this 2 comes from this call right here, right? I see. Sorry, I'm messing up what's happening here. So when we iterate down to here, right? Root dot right. I said this root dot right equals self dot remove leaf node of this. When we get to here, what do we want to return none to this 2 right here, right? So we get here. We call root dot left and root dot right on this. And they both return none. If root dot left equals none and root dot right equals none and root dot val equals target, return none. So we have just done the functionality for this 2 leaf node right here. You return none, and this root, and now we go back to that olders to root dot right call. And we just want to return this new root back to the parent root, which was 1. So we want to return that back to 1. And I believe we got it, right? I believe that's it, yeah. Let's say we do, let's just dry run this. I believe this is our solution. So 1. Next recursive call, root dot left equals 2. And root dot right equals 3. So let's go into both of those paths now. Both of those trees now. We're on 3, right? So the root dot left, so now we're on 3. Let's do root dot left equals self dot remove leaf of root dot left. Let's go into that. Let's go into that path. So we're into 2 path now. If not root, that didn't hit yet. Root dot left equals none, yes, because that'll just hit the base case, and root dot right equals none, so that hit the base case. And now we are here in the step of our code, line 37, and we will hit this line if root dot left okay, yeah, so we'll hit this base case and we'll return it back to that 3, right? And then that 3 will now see its pointer. This pointer will now point at a none, because that's what's getting returned here. And as you can see, our call from that 3 was root.left equals self.remove leaf nodes. So that's right. We'll return none. Let's go to 5. So 3 called root.right on 5. And we are on 5. It's root.left equals none. Hit space case. Root.right equals none. Hit base case. So we are back to the 5. We are back at the 5. And we can return the 5 back as no work was done on it. Return it back to its original call, which was from nodes 3 layer of root.right equals blah 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 blah. Obviously there's a syntax error here that I see. And now let's dry run it on this example. I believe this example actually does just cover all the cases. So yeah. 3. Guys, I'm trying to get better at dry running because clearly that's what's fuming me in these interviews. You know, I failed a interview second round because I couldn't dry run a heap. It was sad. So have mercy on me. 3. Okay, root.left. Root.left equals this, and root.right equals that. So root.left returns none. Okay, let's go down this path now. 3. So we're on the layer of number 2, 3. Root.right, return none. Or root.left, actually. Let's go down to the root.left, layer number 3. And as we can see, we know that it'll hit both base cases because we check its root.left, check its root.right. Both of these will come out to none. Both of these will come out to none. And then we hit this case right here. Then we return this to the original caller. What was the original caller for this? It was from this layer 2, and we had a root.left equals self.remove leaf of the layer 3. And what did we get returned? We got returned a none. So I will also do root.right, and that just hits the base case. So as you can see, we're in layer, forget about layer number 3 right now. It returned none. And because it is post-order traversal now, we can see the work we did with our kids now once we get back to this route. And we can see that layer number 2, 3, both of its calls return none. So now we can see that it also matches the target value. So we can return none back to its original caller, which was this actual route 3. So I'm going to call it layer number 1, 3. Because of that, we returned none from layer number 2. And we already saw that its left child was not there, so that returned none as well. So we'll hit this statement again because of post-order traversal. And then we will just return none for this top 3 in layer number 1. And because that's layer number 1, that's the actual layer, that's the last layer we're on, so that will return none as well. Let us test out our code now. Holy him. Did I get it? Holy him, let's go. Let's go, boys. Day 1 of becoming unchopped. Let's go.